Hello everyone and welcome back to Newegg TV. My name is Paul. Today we once again have a special guest in the studio. This is JJ from ASUS. Hi JJ.
Hello Paul, thanks for having me.
Thank you for coming here. It's great to have you as always. And as I understand, ASUS has finally taken the plunge into the 802.11 AC standard, which is the newest and fastest wireless standard out there. So you brought us a router.
That's correct. We've been very excited about this specification. We've been working on it quite some time. And like you said, we just kind of released this market fairly recently after really working very closely with Broadcom, who actually developed the SoC, so the actual system on chip that powers this actual platform, and spent a lot of time fine-tuning and really kind of trying to push the performance envelope for the users that are looking for the fastest level of performance in terms of the current generation of Wi-Fi. Now with AC, of course, as you can see, is that we've jumped up quite a bit in terms of kind of the throughput marker. These throughput markers are kind of more an outlier in terms of theoretical performance. As you saw maybe on the previous generation units, when we've talked in the past, there's usually a focus at these numbers being closer to about like a 750 or 900, and now we've kind of gone into that next bracket in terms of gigabits in terms of the actual throughput frequency, which is really awesome when you talk about kind of the needs and the requirements for people that are considering high performance connectivity. For things like 1080p streaming, high bit rate streaming, whether it's going to be on-demand video, whether it's going to be high bit rate music, or it's going to be even real-time cloud-based storage services, whether that's the streaming of photos, music, documents, different things like that. You want to be able to have a high-performance router that's the backbone of that system, and that's definitely where the focus is, not only within this product, the RTN AC66U, but also in the 802.11 AC standard in itself. Now, one of the kind of biggest questions that a lot of people ask is, kind of how do you know what router you should be getting based on, the usage model? And what it really comes down to is that people that should be looking at AC probably have larger than standard home environments in terms of not only the range that they're going to require, but also I'd say the concurrent level usage. This is a very important difference in terms of a basic router that might offer dual band connectivity versus a unit that's really focused at a high level of concurrent usage. So when we talk about a router, you've got multiple connections, right? We have, of course, the wireless connections that can exist 2.4 and 5 gigahertz, right? On this unit, of course, it's 2.4 and 5 gigahertz, and then, of course, we have the AC, which you could also be running concurrently, because you could have an AC connection, but then you could still have an 802.11 and 5 gigahertz connection, as well as a 2.4 gigahertz end connection as well. And then when you keep in mind that, of course, that the router has gigabit connection ports, right? That's also another form of concurrent connection. And that's where the AC actually really shines. And we spent a huge amount of work both on the hardware design as well as in the firmware design to be able to extend the performance. I think you were asking me a little bit earlier about kind of what's one of the differences on a hardware design level that we had in this unit, and that came in the form of memory. So this unit actually features 256 megabytes of memory versus many standard routers that only come with maybe 32 to as much as about 128 megabytes.
And is that really going to help, as you mentioned, in concurrent usage? So you might have multiple computers connected, hardwired to the unit. You might have a tablet, multiple smartphones, as well as laptops elsewhere in your household connected via 802.11 AC or 802.11G, depending on what connectivity they have. And the router is having to handle all of that data being transferred back and forth, and the larger cache is going to help it handle all of that?
Yeah, that's really what it comes down to. When you're looking at those concurrent level of connections, whether you're talking about hardline or whether you're talking about wireless, that additional memory is going to help to stabilize and ensure a higher level of throughput performance and ensure that the performance doesn't drop out. It's very similar to kind of like the cache or the memory that you might either have in a physical PC system or like a notebook, or the cache that you have on a CPU memory, on a CPU. So that's kind of one of the key points there. Now, one of the other things that's unique about this unit is also going to be its hardware design in a couple of different respects. One of them you can't see right off the bat, but directly underneath this, we actually have a full aluminum heatsink body. And that actually adds a bit of heft to the unit, but it's also there for the practical purposes of helping to ensure that the SoC, so the actual processor that's built within this, is able to run much cooler over the long term to ensure better reliability, as well as help to ensure better consistent performance. So once again, that kind of dovetails back into when we're talking about concurrent levels of usage. So if you're a user out there that's actively considering that you're using Netflix or maybe Hulu, you're streaming consistently 720p, 1080p video on YouTube, you're using high bit rate playback on things like maybe like Spotify, HD tracks, you're doing, like I said, storage through the cloud services, doing real-time backups. All those concurrent loads are going to add more temperature to the SoC that can produce failure over time, which is one of the reasons why we introduced that heatsink assembly into the unit. Now, outside of that, there's a lot of performance attributes that we take into consideration on what AC is going to provide versus your previous generation. So while we have this really high number right here, the reality is what you're going to get in a real world environment is going to be closer to somewhere between, at the peak end, about 400 to about 500 megabits. But that's outstanding when you consciously think about that what you're going to be able to achieve with that could be, 4, 5, 1080p consistent streams. I've even actually done full 2K video streaming through AC units. Now, there aren't currently any AC clients on the market. So what I mean by that is whether it's like in a notebook or in a tablet or on a desktop, you don't have an AC adapter. So in most situations, it's going to you be connecting to, let's say, a wireless N-based solution. Now in that, to get the best performance from a 3x3 solution, which you asked me about, of course it has 3 antennas, so that indicates that it's a 3x3 solution, you would want to use a high performance 3x3 client. So we have a couple of examples here on the table of 3x3 clients, one in our USB N66 and another one in our EA N66. And we'll definitely be touching more a little bit on those when we take a look at those products. But those are both 3x3 stream clients that could give you easily over 200 megabits of throughput. Now keep in mind when you're talking about what you effectively need to be able to play back something is, when you're talking about HD content, you're going to comfortably start to be looking at about 20 to about 35 megabits is going to give you a really solid quality experience for considering HD content. And you're going to essentially need to look at how many devices you're going to potentially have in that environment that are concurrently pulling out from the router and asking for that resource to be made available to you. So once you kind of start to break that down, that helps you understand where you might need to be at. Now, we are preparing AC solutions that will be coming to market in terms of client adapters so that users can get that highest marker of 400 to maybe about 500 megabits throughput that'll be actually out within about the next month to maybe 2 months. So not that far away, but for users that are looking to get AC performance right now, you do have some great options. You were asking me if a user could create a bridge mode. And you're 100% right. They could definitely take advantage of using our unit and our WRT firmware to be able to create a bridge mode between 2 units. So this unit would serve as essentially your wireless access point, and then at the other end of the house, maybe in, let's say, your wireless, in your media environment, your entertainment center, you could have another unit set up to receive the signal, and then from there, those 4 ports would then connect to all your devices there, giving you that AC to AC wireless performance, but then giving you a really high level throughput through the hard line that you would connect to there, as opposed to having to run maybe a cable across the entire house, which wouldn't necessarily be practical.
So the RTAC 66U you can actually split off. You have dual bands, so you can use one band as a wireless connection. You can use the other band as a bridge.
You could go ahead and do that, but ideally when you're talking about an AC configuration, in terms of a bridge mode, you would be running in that AC primary mode. But you can run concurrent mixed modes. Okay. So what that would mean is that, of course, you could be, let's say, on N, but also doing AC as well. So you've got a lot of flexibility in that regard. Now, some of the other special functions that we want to talk about center definitely around the connectivity once again, which you can see that, for one, in terms of the connectivity right off the bat, we have actually removable antennas. So this allows you to actually have quite a bit of flexibility at being able to upgrade this unit to higher performance, not only in range, but signal strength. So this is going to be a plus point that if you're maybe in a SOHO environment, an SMB environment, maybe you're taking advantage of our wall mount support that we have on the unit, you can go ahead and upgrade the antenna. Most other units that are going to be comparable in this respect have only an integrated antenna and don't give you this level of flexibility.
And that would extend your range and your signal strength?
Correct. Now, in addition to that, of course, we've got 2 high-speed performance ports on here. And not all USB ports are created equal. A lot of users will see USB ports on sometimes much cheaper USB routers, but the actual throughput that's going to be offered is very, very low. There are some units that we've seen where we've measured that the actual throughput is maybe about 3 to maybe 4 megabytes. So this is very, very basic, especially when you consider that you maybe want to start to share music, video files, do backups. This is going to be quite poor in terms of really giving you a great quality of experience. So these are USB 2 ports, but we do offer very good performance from these ports. And on average, depending on the file format system and the network environment, you could be looking at anywhere between about 12 to as much as about 18 megabytes. So this gives you much, much better throughput in terms of not only offering HD streaming, but even the ability ability to do moderate level backups, as well as even having faster print sharing services, assuming you have like a multifunction printer attached to this to share across your network.
So those can service for, say, an external hard drive. You can plug in for network attached storage, or you can also plug in a printer.
Yep, definitely. And we even have additional levels of functionality that are built in, such as we have the ability to do Download Master, which is a built-in application which will allow you to go ahead and plug in HTTP addresses, FTP addresses, torrent addresses, and they can all download directly to the USB hard drive as opposed to downloading locally through your computer. And we also have another new piece of software coming called AI Cloud, which you guys should definitely check out the video that we're going to be doing here, which will go more into that functionality with. From there, of course, we have the WAN port. Now, this WAN port will serve as your normal kind of connection for let's say, your internet. But when this unit is used as an AP, it would actually also serve as a, let me go ahead and take this antenna off here to make it a little bit easier. This port would also be able to be served as a standard Ethernet gigabit port. So technically, while there's 4 ports on there, you could actually have 5 ports.
Nice.
So that's cool. So here you, of course, have the 4 gigabit Ethernet ports, and you're good to go there. And of course, you got your standard stuff like the WPS button, reset button, and of course, a power on and off button as well. So a high degree of connectivity that you have available to the unit, with the rest really being on the inside. When we talk about the firmware, we spend a huge amount of time with the custom firmware being developed. It's called our WTR firmware. This was taken on to a large degree on feedback from users in the community that used DDWRT. And wanted advanced levels of QoS controls. So they wanted traffic monitoring. They wanted built-in VPN support. All that is built right into the unit. Even things like an iTunes media server. So if you have a USB attached storage device on here with music and you're running iTunes, every single one of your systems, if you open up iTunes, would show up this router and you'd be able to access all your content from it. So some really cool available level of functionality that we have built into the unit, really focused at users that are looking for that highest level of performance from both hardline as well as wireless connectivity.
Now, just a quick question going back to the raw throughput of the unit based on the 802.11ac standard. This is a 3x3 unit, and how is the actual breakdown of the amount of bandwidth available on each antenna?
So you have different configurations for your standard 2.4 and your 5 gigahertz. Those are going to be 3x3, so that's going to be 450 megabits. So that's going to take you up to that N900, with the rest being allocated over to the AC specification standard.
Okay.
So that's where your bandwidth breaks down. Now, but speaking actually on one last point on bandwidth, good point that you mentioned in terms of it just kind of considering the whole to total bandwidth, is that we do also have what's called a turbo NAP processor in here, which will affect the throughput for local area connections. So for users that have gigabit Ethernet either on their notebooks or on their desktops, we can provide significantly faster throughput, generally close to about 800 to 900 megabits of throughput performance versus many routers which are only closer to about 500 to about 650 megabits of throughput. So this really allows you to have the highest level of intranet-based connectivity, which is great for maybe if you're running once again, you know, a SOHO environment, small business environment where you have to do data backups across the network, or you're doing, you know, maybe point-to-point transfers or things along those lines, or maybe even running like a virtual machine from another system.
And that's thanks to the high-quality SoC that's integrated?
The SoC, as well as specific optimization on the firmware level to get better performance from the network interfaces.
Excellent. So
that gives a little bit of perspective here on the brand new RTN AC66U.
And that's going to wrap it up for this video, guys. Once again, this has been the ASUS RT AC66U 802.11ac router, and this has been JJ from ASUS. JJ, thanks a lot again for stopping by today.
Thank you for having me.
And if you guys like to see more, you can head over to our Newegg YouTube channel. If you'd like to see more of JJ's videos, you can head over to the ASUS ROG channel. Thanks a lot for watching, everyone. We'll see you next time.